Welcome everyone to another MySound webinar. Am I audible? Am I visible? Excellent. Well, let's get started because I'm very excited about today. So here we go. I'm going to share my screen and let's have a look at the usual household notes. So we're streaming exclusively through the Facebook user community. Welcome to you, to those that are joining us. The Facebook group is currently counting 9,000 members and growing at a steady pace. We're very happy with that. This is our primary channel where we conduct these webinars. And this is going to be another episode that covers aspects of the Precision Toolset, which is our turnkey solution all the way from design to deployment of our loudspeaker products. And that means that I'm very happy to introduce today's host, which is fellow MyerSound colleague Miles Rogers. Miles, are you with us?
Hi, good morning, Merlijn.
Good morning. And I'm tempted to say, take it away, sir.
Well, alrighty, let's jump into this thing. Share my screen. All right. Well, as always, the first order of business is a big thank you to the MyerSound education and marketing teams for this opportunity to talk shop. Today, our focus will be on the importance of designing and building the proper room. Our conversations are all around this on the cinema topic, and well, I should say my conversations are around the cinema topic. And a cinema system is not just your projector, it's not just your loudspeakers, it's not just the room. It's the sum total of all of those components together. And it is mission critical to get the room right. I would argue that if you don't have your room right, you don't have your system right. And so on that topic, continuing with the theme of talking to people who inspire me in this industry and in this world, my guest today is Andrew Steele from Yates Design. Good morning, Andrew.
Good morning, Miles.
So just really quickly, as we jump into this conversation today, I'd like to just kind of talk about Yates Designs, and just maybe for those folks out there that maybe don't know the services that you guys offer and where you're at and what you do, we could just give a quick overview of KYD.
Yeah, so Yates Design is an architecture and engineering firm for critical performance spaces. So our projects are typically two-channel listening rooms or private cinemas, private screening rooms for directors. That's very much the area we operate in, and we've been in operation for 28 years, and we are really focused on achieving just the best experience possible for content consumption, whether that be music or movies. It's all about, for us, it's about experiencing great content and from that, achieving goosebumps and the emotional impact of that content being fully realized.
Yeah, well, I would argue that that is like mission number one, is like, hey, how can we have this experience, right? I mean, if anyone is investing in a cinema system, right, I would hope that they have a love and a passion for film. And the cinematic art is such a dynamic and emotional experience that to hear from you that really the KYD firm is so committed to being able to reproduce that art form in its true nature is exciting. One of the things that I just, as a start off, and talking about KYD, and also I just want to let the audience here get to know you a little bit better. You and I have known each other in the context of the use of MyerSound loudspeakers in your project designs, but there are so many hats that you wear. And this conversation really is going to go into a lot of those subjects, but I was hoping that you could give me just a quick overview of kind of your key functionality for the KYD team.
Right, yes. And so within the KYD team, we have a an engineering team, but we also have a full service architectural team in-house that can document all of our designs, and they develop the concepts for the interiors for these rooms. And we also have project management that helps, with the construction process. So what we're looking at here is the engineering team. But from my position, my title is chief engineer and senior acoustic engineer. And as the chief engineer, I'm supervising, KYD's engineering teams, whether that's the acoustic engineers we have, and we have, specialist acoustic engineers. We have 4 on our team, and they may be specialists in audio algorithms or optimization, or others may have backgrounds in concert hall design, and so they have really in touch with what's required for, concert hall style music experience, and how that translates to a small space, and how we're trying to remove the small room aspects of a design or from a room, and be able to reproduce sort of experiences of that scale in these small spaces. And the other element there is that, those team members who've had the concert hall experience have international construction team experience. So that's great. They might have had projects in Hong Kong or Toronto. So they have just this, it's really powerful for our international projects to have people who have this awareness of the different construction, constraints or realities in different parts of the world. So we also have noise and vibration engineers who specialize just on achieving our low noise criteria, technical power system engineering, to make sure that we have a clean power supply, that certain elements in the system are away from, that are isolated from maybe some obnoxious noise, like noisy electrically noisy sources in the house, or the site. That also includes ensuring we have a good ground on the project. And so it's an extensive program, the technical power system engineering, when it's involved on projects. And we also have indoor air quality engineering. We're very focused on achieving high quality indoor air, and I think we'll cover a bit of that later. But there's also the mechanical HVAC engineering as well. That's a KYD service that we design the full mechanical service for the project. So what I'm doing under that role is ensuring that we're meeting our technical performance metrics. We've got very strict and aspirational metrics we look to achieve on each project at the different levels, and my role is to sort of oversee all of these teams and make sure we're hitting those goals consistently. As a senior, in my role as actual acoustic engineer, my background is primarily room acoustics, and that was my focus. I grew up as an avid speaker builder, and quickly realized that really the end result is speaker and room. And being in Australia, there's not many speaker manufacturers, so I went into room acoustic design, being that there's more acoustic consultancy firms there. So if I grew up in California, I may be a speaker engineer, who knows. But yeah, my focus really went into from speaker building and design into room acoustics. So my background is really focused on the different simulation methods, whether that's a high frequency, where we might use ray-based or geometrical acoustic modeling methods, or finite element, which is a wave-based method, so that we can simulate the low frequencies accurately in our rooms. I also am involved very much in the AV specification on our projects, acoustic measurements on site, audio system calibration, and I had quite a large role in defining and developing the engineering sequence for our UberSub program, which is not just a product but also a room as a system approach we take.
Nice. The common theme that I'm really picking up here is that you're across the prediction, the implementation and the verification of system performance, as that relates to the whole system, including the room. And that's such a nice place. A nice thing to hear is that, you can see that from start to through implementation to finish of the project, and I've certainly, as you and I have talked about the different projects we've been involved in, have learned a lot from you over our conversations, and hopefully, through that, what we can offer the audience today is a little bit of the insight into your world on all these, these are really technical topics, right? I mean, if we just look at indoor air quality, right? That's
Right.
something that I don't really think about, but yeah, I guess it's pretty important to have clean, oxygen in your room, right?
Yes, yes, and each one of these topics, yeah, that's right. Having enough oxygen, and having low particulate count and clean air on this room that's got recirculated air, but also enough fresh air is very important.
Yeah. Yeah. I mean, it seems simple, right? But
It does, it does, and
turns
each
out.
each one of these topics, we could talk about it for a day. Each one of these points, and it's something that because we're really looking at achieving, what do we need to do to get there, and dig even deeper in the immersive experience. So we are always pushing those boundaries and identifying like where's the next place that's going to improve our clients projects. But these are sort of what we consider the main areas to look at for designing a private cinema.
Nice. Well, and hopefully what we'll accomplish is planting some seeds to let those seeds grow, as people realize, oh man, there are a lot of steps and requirements into making sure that the room is right, and ideally you hit every single one of those metrics spot on, right? And that's what you guys do best. But any movement in that direction to getting the room better is a win, in my opinion.
Right.
So just really quickly, just a point of clarification around our conversation is that, I really kind of think about rooms in two main types when we're talking about residential systems. Is that we've got the private cinema, which is really a purpose-built room designed for the best performance, audio and picture performance for cinematic content, but we also get into media rooms, like the image that we have here, where this is really built around maybe a living space where people are going to come in and out, and the system has to more or less fit around the space that's available and the look. But so I'll try for this conversation, and maybe Andrew, you can help me out as to to be clear what points, whether we're talking about private cinema or media rooms. But for the most part, we're really going to focus on that private cinema, that purpose-built dedicated room. So I don't know if you had anything you wanted to add to that particular topic, but let's do this. Let's jump in. What do you say?
Yeah, I agree. Let's jump in.
Nice. So, this all has to start somewhere, right? And I think that's a crucial piece is what are the first steps that you take when you're about to take on a new room, a new design? Where does this all come together?
Right. So we like to meet with the client very early in a project's conception and get together with them and identify like what is this venue going to do? What are we really trying to achieve here? And we have an explorative process that we work through with them, and we identify primary uses of the room, like media playback requirements. We try to really understand if they, are withholding the fact that they like watching, consume a whole lot of concert videos, for example, or if they're really focused on 2-channel playback as well in this dedicated room.
You go ahead and mute your phone and get it if you need. I
It's
don't
fine.
interrupt business.
It's no problem. So we're looking at the media playback requirements as well. So we're looking at the content, and we're also looking at the media playback requirements. We, within the media playback requirements, that may be different formats that they might be trying to use. But we're really looking at the primary use. How many people are we going to have in this room, and and how do we configure the big chunks?
Right. Well, you know,
Sorry.
and that's actually it's quite all right. You know, it's actually all your friends that are watching us right now say, "Hey, let me on this webcast." But you know, just to say it is that it is so crucial to understand the you know what your customer is looking to do. You know, and this from the audio loudspeaker standpoint, right? You know, we're in this exciting new world where it's not just about you know a standard 5.1 or a 7.1 implementation, right? We've got all the immersive formats that we would want to consider as well, and so having that conversation really, I would assume, gives you a really good scope on what the project is looking to shape up to be.
Right. And just coming back to the big chunks element as well, is that, you know, there's considerable amount of support spaces, considerable support spaces and location relative to other areas of the house that or venue that we might be looking at with the client. And so it's getting in early, before even if the, you know, even if possible before the architect starts doing some preliminary planning on the house, and or the site, and identifying where can we locate this, where is it maybe away from some noise sources, can we have it closer to you know, mechanical services rooms, is the logic laid out for actually, you know, the the all the support elements that are needed to make the room a success. It's not just the, you know, the rooms position in the house. It's the room as a system. So we're looking at all of those things early on, but just to sort of like to start to carve out, and and um, identify what we're trying to achieve this room. And that's kind of a beautiful thing, is that the, you know, we are creating this, you know, totally custom room design, and you know, we're very fortunate to have fantastic clients who, you know, I think, as you just touched on earlier, is that um, they are um, avid maybe consumers of music or movies, and the emotional impact of movies and music might strike a chord with them. So, you know, that's, you know, at the end of the day, for us, it might be goosebumps that drives us, or those experiences we've had with content that is why, you know, I'm here as an acoustic engineer in this company. And but it's like the great thing is that most of what we find is that the clients that come to KYD are also looking for that same thing, and there's a great alignment there. So um, but you know, that's kind of the great thing, is that we get to work through this design process with them, and identify like how can we you know, create this space for you.
Yeah, that's so nice when you can have shared vision, you know, and really just make sure that you guys are lockstep as you work forward. Because, you know, these aren't simple projects. I would assume it takes more than a weekend to accomplish one of these projects. So,
Considerable, yes, there's a considerable amount of work that goes into this. That's right.
nice. So, you know, that's you've got the scope of the project. You're lockstep with the client, and you feel like you've got good vision on the path forward. You know, you got to put your team together, right? And you actually touched on something that's really interesting to me, which is, you know, these projects aren't all happening in one state or in one country, right? These are
Hmm.
global projects, and so, you know, you have relationships, and your team has relationships with all of the trades, you know, around the world that can actually accomplish a project on this level. You know, talk about assembling that team and who goes into that team.
Yeah, right. So the execution of a room is critically dependent on everyone that's involved in that project. So I'd say that starts with the system integrator, or the AV integrator. Some people might know it as, but that's the team who's going to sell the equipment. They're going to install that equipment into the room. They're going to do all the do all the integration, build the racks, and design the user interface. But they're really key, such a key player in all of our projects, and they're really tied to the success. So you know, that integration firm we're working with, that's hugely important. And then the project architect, you know, within that as well, we've got interior designers, lighting designers we might be coordinating with, the general contractor. Um, you know, sometimes if it's a remote project, we actually go through a general, like a vetting process with the client to identify the right general contractor. And of course, there's all the other trades. So the the specialty subcontractors, electrical, HVAC, plumbing, but all of those trades go into creating this room. And you know, there's education throughout this process. Sometimes these residential spaces we work with, the general contractor, you know, they're not a studio general contractor, and we might be working in the middle of Connecticut for a project. So, you know, that general contractor in that area that we're working with, there's an education and a coaching process so that they understand what we're trying to achieve and why we're trying to achieve it. And sometimes it can be I think sometimes it can we can be still working with them up until opening night, and when they finally experience that. They finally experience the outcome because what we've specified is so far beyond what they may have seen before. It's only at opening night when they get to finally experience a finished room, then they have that, oh, so this is why they get that, they have that realization, you know, at the opening night. So but that's always great to see that there's this this is a turning point. Sometimes it is the turning point on opening night. So but you know, the team is this team is huge, and then obviously, like with a project, we like to get in very early with the loudspeaker manufacturer, the projection manufacturer, screen manufacturer, and the custom seating manufacturer, because all of those elements are, you know, crucial for the room's success, and, you know, making sure that we're going to actually be able to logistically get, you know, elements into the room, and, you know, making sure that we've got a system that's designed, that's on track to performing as we're looking to achieve for the project.
Right. You know, you touched on one point that I think is maybe overlooked, but is really important, which is opening night is the term you use, right? You know, when that system is all done, you know, having the opportunity that, you know, the people that have been involved in the execution of that project to be able to see that end result, you know, the all of their hard work, and, you know, having to maybe rework something, or you know, just the level of intricacy that goes into it, right? You know, having the opportunity when the project is done to come back and experience that, you know, that's something that I love. You know, when I get involved as a calibration engineer, when we finally bring that system together and can play the first piece of content, you know, you see the heads poke in the door and people are like, hey, what's going on here? You know, mind if I hang out? And it's important to give that energy back to the team, you know, because again, you know, we're all in this for obviously work, but also our love and our passion, you know, and that's going to drive these projects to be, you know, just that next level up.
Yeah, and we also encourage our clients to have an opening night to celebrate, you know, the construction, like, and actually it's an opening night party for the construction team that was involved. So everyone who, you know, drilled screws into the wall assembly, you know, they're invited with their wives to, you know, and champagne's handed out, and everyone gets to experience this, you know, this final space that they have put so much time and effort into, because it's, you know, it's thousands of man hours that go into the construction of these rooms. So to sort of celebrate everyone that was involved is you know, it's a really nice sort of detail that we get to, you know, that some of our clients get to throw for, you know, the construction teams.
Yeah, that's right. That's great. I like to hear that, man. You know, we're not just worker bees. We are human
Yeah.
beings, you know, all connected on this adventure together. So just moving down the path, you know, tell me a little bit about the process of design, right? You know, I mean, we're hinting at all these pieces, but you know, there's really, you've got this team together, you know, you're really trying to figure out how you're going to execute all this, but you also have, you know, now that you have talked to the client and you know which direction you're going, now you really get into that next step, you know, that process of designing the system. You know, give me an overview of that process.
Right, and so yeah, we're you know, that process, we're looking at these important factors of the room, right? And this room is coming together as a system. So it's the, it's the acoustics, and under that umbrella is the room acoustics and all of the elements that are, are huge subjects of them are their own. But the loudspeaker system is a key part of that. The performance of that loudspeaker system and the characteristics of that system are critical, as well as the room acoustic treatments, specific geometry of the room. Those are all important factors. And so we're looking at this this space as a multi-objective or there's multiple factors we're looking at that are more than one discipline. They're usually mechanical. So we've got our architectural team. We've got egress requirements. We've also got architectural theming we're trying to achieve to create a really welcoming and pleasant space to be in. Because a black and all black a velvet or black velvet room is not necessarily an enjoyable space to walk into. So we're designing these great architectural spaces, but also that we're also including these significantly sized mechanical systems to achieve our low noise and flow and air change requirements. There's the noise and vibration engineering requirements. So the location, as I mentioned before, the location in the house or the project, where it is located. Is it away from things like a lift shaft or mechanical room? And are we is it going to help us get to the noise criteria we're looking to achieve?
So really quickly, do you have the opportunity to influence where that mechanical goes in a space, or is it, you walk in and it's basically predefined? I mean, I would assume that it would change as per project, but they're just thinking about air handling and the amount of vibration from these systems, is that where those go is mission critical.
Oh, it's huge. It's hugely mission critical, and it's something when we're designing a project, it's one of the first things we look at. The locate, like the actual, obviously an initial seating layout. We're looking at placeholders for technical cavities, which is where we'd have our acoustics and speakers, and then the isolated envelope. And then after that, we're looking at mechanical system. What size do the ducts need to be for this volume of room? And then, how do we get those ducts to an equipment room? And do we have, can we locate attenuation within those duct runs on the way to the room? And these are all, I would say, studio size or greater mechanical systems, and they're significant. So it's unusual for residential space to have mechanical of this size, but it's like we just need to design it and accommodate and plan for it early on. So it can help us identify that one room may not be appropriate, and we'll go to the client and say, we'll look at the floor plan with them and say, okay, we need this either for even, the projection booth may need to have specific depth based on what kind of projection they're looking at, and to make sure we've got those spaces allocated just from the outset is a huge factor. So yep.
Sorry, that's when you tell the customer that they need to excavate, right? You're gonna have to dig down and go 10 feet down.
Yeah, we like excavation absolutely. Yeah. That it's just you're at a floor level, and you were talking about rake seating, and it's quite nice to come in from the rear of the room. So that's a reality that we sometimes go down relative to the rest of that slab that might be at the lower level of the house. So so the important coming just discussing these important factors. These are all significant elements to look at, even early on, but even as we keep working through the project and designing it. So, as we go and start to, define the project in more detail and work through it, we're obviously looking at all of these elements as we keep continuing working through. And your mechanical and the acoustics are always working together to achieve both objectives. So it's a very much collaborative process, and we're looking at specific auditory and visual perception metrics while we're designing these rooms, and that's sort of like a the DNA of this company is all about, the physical and perceptual metrics that that drive immersion and remove distraction from a viewing experience. But and just leading from that as well, that like drives a movie friendly interior design. So there's certain colors or certain hues or bright fabrics that may not be permitted in a project, but we work with the interior design team or our own interior design team in house to define a fabric and an interior theming that works well for when the lights go off, because that's ultimately critical for a private cinema. What we're all there for at the end of the day is to watch that feature film and for everything to just fade away. So
and you talk about how important it is to have for the lights on versus the lights off experience of the room, right?
Right. That's absolutely. So when you're in, when you're in the room, it's like, we actually find that sometimes a lot of clients say to us, I just go in there and read. Like I spend so much time in there. It's such a peaceful, quiet space. Like just significant, like noticeably more quiet and like a relaxed space to be in. That they just go in and read books or spend quite a lot of time in there. And it's not to do with the content consumption. So we really like developing some great architecture, and we've got we've got an exciting team to work with in KYD to sort of come through some concepts for clients. So
that's great.
Yeah,
nice. That's we talk about the design of the system, and of course this is where I get involved, and I'm going to tell you this is the most important point, right? That's that's my world, is that loudspeaker systems, right? This is our engagement, and this is really where you and I will start to talk about a project, and make sure that we're headed down the same path. That not only are you up to speed with current products and implementations, but that you have the information about the products to really execute the design that you're honing in on in this process. Tell me a little bit about your process and what you go through when you're really defining the loudspeaker system and the layout.
Right. So one of the first things we'll do is look at the surround formats that we're looking to achieve for a project, and that it might be Dolby Atmos or a 3D. And that can be much more relevant in some areas of the world where or a 3D is on Blu-rays and it's distributed thoroughly there as well. But DTSX, MPEG-H, these are all formats we're thinking about. And so there's hybrid, there's a high, if you followed each layout or your surround format, you might end up with a slightly different, you might end up with multiple overlapping speakers. So we define speaker layouts that work for all formats. And when we're looking at speakers, we're looking at audience coverage, we're looking at energy that goes to sidewalls, and we're looking at the linearity of the speaker. Like when we're talking about when we talk about reference level and the headroom that's required for reference level playback, those are very significant things for a room. Like if the room on the right here, that's a very decent sized space, and the sound pressure level that's required, the linear sound pressure level output that's required from those speakers is significant compared to what you would be accustomed to for even just like two channel playback. So the linearity throughout the entire dynamic range of the speaker is a huge element for us. And within that, that means low distortion, and we're also looking at consistent coverage patterns from those speakers. So we want the whole audience that's in this room to experience an equal in a similar playback experience. We don't want it just to be all focused on only one seat. So the consistent coverage patterns and the off-axis response, which we refer to as a power response of the speaker, all go into sort of contributing to the voicing of that speaker. And so that's really important. So for when you say go from the screen speakers and take an an object and it's panned off screen and it goes around the surrounds or it goes over the top speakers. The fact that all those speakers have been designed with this as a system or as a series, say a cinema series of speakers, is all critically important to us. That they are all they all have similar voicing, and they have these characteristics that enable us to achieve this maximum output required for a project. So and the great thing is that as a system specifier, the Meyer Sound product line does that for us. It's obvious that there's been a lot of thought that was put into the conception of the product line, and as you scale the room, there is a product to scale up, or as it gets smaller, there's a product that's appropriate to go down as well. And it makes sense that there's not large discrepancies in the product line. There's a consistent logic behind it. So our job as engineers are made simpler because the loudspeaker product that we need is there. So
when you touched on a really interesting point, and this is certainly the way that I look at the loudspeaker world is that it's systems of loudspeakers, right? We're not just talking about a single loudspeaker, a mono channel in a room. I mean, especially now as we get into these immersive formats where, we at the very least have 16 loudspeakers, or many more, right? I mean, if we get into the DCI compliant systems, where you can have upward of 64 loudspeakers, it's how they work together,
right.
and it's really, I love hearing it from you because it's something that I say often. It's important that as sounds, transition from the screen into the surround arrays, that is a seamless transition, and really the goal, the dragon that we're chasing here is to create this sonic bubble that we're within, right? And having consistent coverage and low distortion loudspeakers that scale through the entire dynamic range, that's something that, at least at Meyer Sound, we put a lot of time and effort into making sure that our product offering achieves that. And it's really nice to hear it come back from you to say that those are important factors for your design criteria.
Yeah, absolutely. And I just can't, I can't reiterate that, I want to reiterate that it's so critical that speaker selection and the specification of the speaker, it's a huge part of the system. And, obviously the room acoustics are the second, it's like, I would say they're an equally married importance for the outcome of the final room. But it is about that bubble. It is about the fact that are the speakers just disappearing? Because once you have if you're sitting in a particular seat and all you're hearing is like the left speaker or the right speaker by itself, that's not a great thing. What we want is just this immersive bubble that is just rendered accurately and with linearity with whatever content's being fed into it. So it's the fact that the speakers disappear, and on all of our projects the speakers are behind fabric. We don't see any speakers or acoustics. It's all architecturally
it's visually
designed,
transparent.
visually it's visually opaque. You can't see anything, but visually it looks great. But then we have very, very, very highly acoustic transmissive fabrics that we select on these projects. So it's just
and just to say it, when it comes to fabric in front of loudspeakers, that's something that we want to make sure you got the right stuff there, because if it's having a negative impact on the performance or the coverage or the tonal response of that loudspeaker, maybe that's not the best selection. And so it's great to hear that you guys are very, very aware and getting into that fabric testing. So one thing that I want to kind of move into here, and I think is really interesting, is we're talking about loudspeakers, and one of the the fundamental channels of any cinematic system is that low frequency effect channel, right? It's the subwoofers that really are reproducing, the bottom end experience, giving you that visceral LFE, or that low frequency. And KYD has a really, great approach to how you guys design and specify and implement LFE in your rooms. And I was hoping that you would take a moment to talk about that. And, I've jumped to this next slide because maybe you can tell me what's going on here. Give me an idea of the KYD approach.
Yeah, right. So we are looking to achieve clean, crunchy, tactile bass on our projects, right? So that's the objective, is that we're produce, because LFE is something that can just really transport you to another place. It's something that in a residential space or in a home or a private cinema, that the accurate reproduction of that either there's very subtle low level background noise from, say, a freight train rolling past, while someone's sitting in a cornfield, that's captured in the soundtrack with these microphones. So they're flat to DC, most of them, that are taken out into the field to capture sound. So we want to reproduce anything that's in the soundtrack linearly, and with total linearity. So but then the thing that's made it much more complex is with the rooms we're working with, the private cinema scale room. Reality is we have significant modal effects that are influencing the ability to provide consistency low frequency response at each seat. So what we've got on this picture here is on the top two pictures, we have a sound pressure level slice through the audience area, and between and so on the left room we have it's the room, a 2-row room, and there's a row of seats, and there's a bar counter behind it. And in the image you can see that there's some round circles that are opaque on the graph, and that represents a head location. So on the left we have a subwoofer in the rear right corner, and this plot actually would look pretty much the same whether you had that subwoofer in the front right or front left, or the rear right corner. So it's in the rear left corner, the source, and this is the 110 mode. It's at 38.1 hertz for this project, and it this from here you can see there's about a 30 dB, a 30 decibel difference between the red and the dark blue. So the two outside heads on that rear row are experiencing very high sound pressure levels, while the center seat in the front row, which would be the the client's primary listening seat, probably is in a cancellation zone for the room mode. So first thing is you can't EQ out of that, and you don't want to EQ out of that. So that primary listening seat is going to be at that specific frequency is going to be experiencing low sound pressure level, and these other two audience members on the far outside are experiencing high sound pressure level. So there has been some fantastic research done on rectangular rooms with generic audience areas, and generic head locations in audiences, and that was work with Harmon and Todd Welty and Alan Devantier. Floyd Toole was involved in that as well. They defined something. They did a lot of research and defined some great parameters for the industry to apply to those rooms, rectangular rooms, where you don't really know specifically where the audience will be. So they came out of that with some really good foundational kind of guidance for designers for these rooms of this size to apply to achieve more consistent low frequency response across the audience. So what we have within KYD is a program which we call Basecamp. It's a service that we offer, and the thing that we get to the great thing that we get to do is actually identify the specific room geometry, because as soon as you go from, because you can have a room mode plotting tool, there's plenty online that you can go into the length, width, and height of a room, and it'll plot all of the room modes for you very nicely, and it's very accurate if your room is rectangular, assuming all the boundaries are similar. That's there's some few caveats there, but generally you're going to get a pretty good picture of what the standing waves are and what frequencies they will be at. So the issue is, though, as soon as you start adding any geometric element to the room that doesn't fit that rectangular box, say it's a seating platform or a soffit that's showing like this, or some elements to the front of the room, those standing wave or room mode calculators they go out of the window pretty much after the first main axial mode. So we go very quickly to find an element from the start of the project. So before we get to here, would be looking at just basic audience head positions in the room, and how that actual physical room we're designing and looking at is where those natural frequencies are for the room, and where the nulls are, and where we just don't want to put audience head locations. But but the Basecamp program, what we do there is we have what we call it's called a finite element model that uses computational fluid dynamics. It's a wave-based simulation, so we're simulating accurately what the room's low frequency response would be in that room with those specific head locations, and we were able to identify specific, multiple subwoofer locations in the room, and then run a simulation and optimization process that identifies where would the best subwoofer locations be for that room, for that audience, and for that geometry. So, and that's very specific for improving the seat-to-seat, the difference between each seat. So you can see in this after plot here, we now have, and I think this range here, we're talking about between the sort of the green and the blue there, that's something like a 2 dB difference. So for that frequency, now that audience, instead of being, I think it was something like 20 dB in the left plot, between those two seat locations, we're now down to 2 dB difference for that frequency. So we've got the full bandwidth as well. So it's looking at all the frequencies for this optimization, but this is just one frequency as an example. But you can see that the whole audience area is consistent now, and that's the biggest sort of challenge, is that for a dubbing studio, one seat is really important, right? So you can position someone in the room at a specific location. It's sort of it's a one. It's really critical for just a few seats to be perfect, and then but with what we're doing with these private cinemas, we're looking to achieve that consistent and great low frequency response for everybody.
Yeah, and that's really interesting point. It's just minimizing the seat to seat variation, right? This is something that, as the room volumes go up, we can have relatively consistent low frequency performance across larger sections of the audience area. But as that room volume comes down, especially as we're into these private cinematic rooms,
yep.
It's no joke. It really is, and it is, especially from our relationship and the way we work together, is that it's, yes, we can specify the loudspeakers, but it's so crucial that we work together on how those loudspeakers are going into the room, and that you and I have a coordination of what product and how that room is going to interact. And and then, of course, what's really interesting to me is getting into this other product that you guys offer through KYD, which is really getting into that LF extension into the infrasonic, right? I mean, we define the LFE channel as 25 hertz to 125 hertz, and that's pretty consistent of what we're trying to reproduce. But what we know is that there's content that lives on these soundtracks that's below that 25 hertz, and might be even getting down into that 10 or 7 hertz range.
Right.
And this is something that you guys are really familiar with, and get into developing these subwoofer or LFE systems that can go down into that infrasonic range and linearly reproduce those low frequencies, so that it can become a constructive part of the sound design, and add this whole other emotional element of impact and And in some cases, that low frequency is used to put you on the edge of your seat, to indicate something's happening. But tell me a little bit about that design process and that focus on getting into those frequencies that are below 25 hertz.
Right, and yeah, absolutely. The infrasound, is we look at the auditory, visual, and haptic or tactile elements, like when we're looking at a whole room. So, we think each one of these are very, very important. So when we start looking at the haptic and tactile, infrasound doesn't necessarily mean haptic and tactile. It's not just about feeling. It's the fact is that when we look at human hearing thresholds, within the actual within the dynamic bandwidth of reference level playback for the LFE channel, you can actually hear, like, the threshold for these low frequencies are you can definitely hear those below 20 hertz. Usually it's quoted that the human hearing range is 20 hertz to 20 kilohertz. And actually, we can easily hear 10 hertz, before we get to the, total, before we even see the peak level of these, of what's possible to encode in an LFE soundtrack. So it's not just about achieving something that's feelable. It's also about the fact it is audible there. And we've experienced a lot of these different, we've experienced a lot of different effects in our lives, whether that's closing a door, is interesting, like just things we do day to day, like closing a car door or even closing a door in our house. They create this infrasonic pulse of energy that is just part of reality. And as I mentioned before, say a freight train going past, or whether it's an explosion or a waterfall, all of these things in nature, we always have infrasound around us. And so we focus on taking everything away in terms of providing great sound isolation, but like really removing as much background noise as we can, and then filling that back in with what's in the actual content. So, whether that's a 5-second long 5 hertz sine wave in Black Hawk Down at 0 dB at 0 dBFS, like that's what's the we or if it's the impulsive thuds of the horse's hooves in Seabiscuit, or just the infrasonic ambience. Like we want to reproduce whatever's encoded in that LFE track, and there's nothing, like, it's not necessarily musical. Sometimes it's like the director's taking you to a different place, right? We could use Tron as an example. Like there's a world that's been invented, or an experience has been invented, and the sound designers and the directors are taking you somewhere, and there's no rules. Like within that LFE sound, like within that LFE channel, they can put whatever they want as long as it's not clipping, right? So we want, like, whatever they encode in there, we want to be able to play back that truthfully without the system, reducing output within 3 seconds. So that 5 hertz sine wave example from Black Hawk Down is a great example of, like, we want to design and specify so that there's total linearity. So when we looked at the how we could achieve this in projects, KYD's been doing various versions of infrasonic, implementation for, I think, since like 1997, and there's been 3 major steps in that process. And what I'm going to talk about is the current implementation. So we looked at like how can we, because we had some infrasonic solutions that previously may have had a 9 hertz cutoff frequency because it was maybe a 6-order bandpass, or with passive radiators, and it was phenomenal. But then we really looked at it and realized that with our private cinema designs, we have control on the room design, we have control on the shape and size and what the boundaries are made of, and we realized that with the volume we had, that we could really use the pressure gain that's available below the modal range to complement the roll off of a sealed subwoofer. So we've gone and we also looked at our baffle walls, which I think we'll touch on as well. But we looked at our baffle walls and realized that we have a lot of volume in these. We're not utilizing it all. So could we use the baffle walls that are already there on a project, and and design them as custom one-off speaker enclosures. So we have these 50 cubic foot modules that get taken onto the site, and you can kind of see a few of them here, and they're internally braced. We do FEA analysis on each enclosure for internal resonances and also structural modes, and we'll change reinforcement to sort of match. So each one of these is a custom designed loudspeaker, as if we were going to make 1,000 of them. So like when we're just talking about these custom enclosures, that's the level of detail we're going into. But each one of these is a 50 cubic foot internal volume, and then we have modules with two 24-inch subwoofers that have a 2.5-inch peak-to-peak excursion. So they are force canceling. They're attached in a machined aluminium enclosure, and so because they're facing each other in these assemblies, there's no, because we're talking about a lot of potential force from all of these woofers moving at 5 hertz, 2 inches peak to peak or more. So we wanted to make sure that there was no energy transferred from those cones moving to the actual baffle wall, or to the theater structure. So that's kind of a key element, but it's more than just the subwoofer it's more than just throwing a whole bunch of subwoofers at the room and hoping that it's good. So we have a very thorough process for first doing an initial concept finite element model to identify the actual relationship between, or how the Uber subs interact with the room. Because when we're talking about when we started this, we looked at recording studio textbooks, we looked at room design textbooks, all about what's in there for infrasounds or the pressure region, and they had maybe one sentence and said below the modal range is the pressure region. So we had to really go and really understand and define our own program to design this, because what we wanted to do was tell the client, we can give you say 120 dB at 10 hertz, and that's going to be like that's what we measure with low distortion at the end of the project. So to deliver that is a significant amount of sound pressure level at that frequency. So we have a robust process of designing. We'll do an initial finite element simulation of the room. There's some really interesting things that happen between modal range and pressure region, where you can end up with just an excellent no output at specific rows if you put the subwoofers in the wrong place, the infrasonic subwoofers in the wrong place. So we look at the geometry, we look at their placement, and then we have a series of verification steps during the project. So even at the early stage, we'll be looking at what the walls are made of and calculating what the boundary impedance will be and inserting that into the finite element model. And then we have another step during our testing phases where we actually do a pressure room gain measurements at the infrasonic region and use that to calibrate the finite element model. And then we feed that back and do another simulation to confirm that we're still on track to achieving the sound pressure level at the end. Because at the end of the day, we have to achieve, we've told the client that we are going to achieve that 120 dB at 10 hertz. Yeah. And we're now seeing projects, because of the experience we're gaining, we're actually seeing minus 3 dB at 3 hertz in projects. Wow. But it's still there's quite a lot of things that start to happen below 10 hertz in a room. So right. It's a robust, yeah.
Sorry to interrupt. Just to interject there is that, what's really the key takeaway here is that, there is a system that you guys have developed for really getting in and turning that room and that low frequency experience, into a study that you've gotten into. And maybe the takeaway seed from this part of the conversation is that, as designing rooms, it's really crucial to look at placement of low frequency elements for the LFE channel and how they interact with that space to make sure that, again, the end goal being to minimize that seat to seat variation, and also to know what your extension or your frequency response of that LFE channel is going to be as you dig into those lower frequencies. And like we warned everyone here, we can go off on this for a long time. I noticed we're probably supposed to wrap this thing up in 2 minutes, and we have at least an hour worth of conversation left to be had. So I want to just really quickly kind of hammer through a couple things, and
Yeah.
if Merlin, I'll leave it to you to cut us off when you're ready for us to be done.
Oh no, we're good. We're good.
Nice. So just really quickly, as moving forward in our conversation,
Hmm.
talking about baffle walls. Baffle walls are important in my opinion. Give me, what is the KYD statement on a baffle wall in a system?
The KYD statements is a pretty solid one, because KYD's been designing large, stout, well damped, inert, acoustically baffle walls since 1993, and we've been doing that in all of our residential projects. So that's really there to give the screen speakers a 2 pi or a half space radiation environment required to neutralize sonic colorations from the front wall. So there'd be, if the screen speakers were just sitting 2 feet from the front wall, that's low frequency energy is going to hit the front wall and come back as a speaker boundary interference reflection, and cause cancellation in the audience. So it's about that, and also about instead of that energy going back and being interfering with the actual radiation from the screen speaker, it actually reduces the, you're getting more output. You might see 3 to 4 dB at low frequencies from the fact that you've installed the speaker in a baffle wall, and that's significant. The energy required at 125 hertz is quite is huge. But the fact that the fact that the speakers are already competent and could produce that sound pressure level without the baffle wall, the fact that we add the baffle wall we actually just get to lower the output of that, and that means lower distortion, and we've got just cleaner playback and better dynamics for the room. So
Yeah.
that's sort of like the reason we're doing baffle walls. Like it's
Yeah.
all about,
Well, and
it's a considerable like element for these screen speakers that are so important.
it's a huge region in the room right behind the screen
Hmm.
where you have this opportunity to really put in some more absorption into the space, and where you may not have that in the side wall, the ceiling, or the back of the wall.
Right.
There's huge advantages to using every inch of space you have in
Hmm.
your room.
Yeah.
um, just really quickly, this is something that people might not think about, and we've touched on it, but this is the level of infrastructure that goes into HVAC and the indoor air quality is substantial. And you've even said it's on par with the studio level, because of the equipment that's going to these rooms
Hmm.
oftentimes. Just give me a real quick overview of this approach.
Yeah. So with a private screening room, what we have is 15, 20, 25, 30 people in a room. That's not designed, that typically residentially you wouldn't put that many people in a room that's perfectly sealed because of the sound isolation we've developed. Usually sometimes rooms will just have a bit of natural leak to them, but there's no air coming in under the door. But you wouldn't normally put that many people in a room, close the door, and not give them any fresh air for 2 hours. So um, most, and it's and we find that most mechanical systems are just designed as like, oh, it's another room in the house, we'll just give it the standard amount of airflow or fresh air, and that's a huge mistake, because sometimes people come out of watching a movie and they feel kind of a bit lethargic, and they might put it down to the fact that they've been in a dark environment for 2 hours, but it's actually the fact that the CO2 levels have risen while they're watching the movie, and they might be feeling the effects of that. So to provide very low noise, like this project here, we can see 3 spaces that it's serving. The orange is the return air, the green is the supply, but we've got the primary theater on the left, in the top image on the left, an equipment room, so all the cooling required for that in the middle, and then on the right, we've got the client had a 2-channel dedicated listening room. So, but for each of those spaces, we had dedicated duct runs and a symmetrical duct layout, so we had even flow and velocity throughout the system. But there's a whole, to do it right, to get the indoor air quality perfect, and to get the noise criteria down to say NCB5 levels, which is significant, like extremely significant and impactful for a project. It takes a lot of coordination. It takes quite large docks, and it takes takes some real estate to get there. But at the end, what we achieve is these you've got these noise criteria levels or that are approaching human hearing threshold. And we think that's extremely relevant, because when you look at spaces like a concert hall, you can have concert halls that are NCB 10, and we realized that the dubbing stages that these movies are mixed in might have noise criteria or background noise levels of NCB 25, NC 20. But our philosophy is that if we just remove everything and we can let the content add the background levels back in that were captured, then that's what we're looking to achieve. And to remove all distractions. And so that doesn't just apply to so just coming back to going lower, that means that if the client doesn't want to listen to reference level, they can actually hear the full dynamic range at minus 10 if they had the gain turned down. So they're hearing, like, as we can, our hearing threshold's incredibly low. And we're used to being in residential environments where the noise criteria just in a normal house is at around NC 20, maybe really quiet bedrooms NCB 15 in a rural environment. But we're not used to having these environments where we go and close a door and it's just like there's just this absence of sort of background energy all around us. So we're about creating this environment where we've got a very neutral, quiet background noise. And not all of our projects hit the NC 5 design criteria. We've got projects where we've got NCB 10 and 15 because the realities of actual NCB 5 is incredibly, as that previous project we just saw was an NCB 5 design project, and this was the actual curve we achieved, and you can see it was just, for most frequencies, we're below the actual hearing threshold. So that's hugely significant.
So one point I really want to make here is, or maybe for you to make, is that low NC isn't anechoic, right? We're not talking about anechoic rooms. We're talking about background noise.
That's correct. And sometimes some people who might have experienced anechoic spaces or highly damp spaces where you have just absorption everywhere, those spaces are usually quiet, and they may associate that quiet experience with something that's not pleasant. And the issue there is with those spaces that are anechoic, our senses, our auditory or our visual senses, they want to have cues that match what we're seeing. So if we're seeing a wall, we want to actually be able to hear it. So when we're even just moving around, we make noise, or if you're talking, or even just our footsteps moving around a space, we're getting energy back from all of the surfaces around us. And so if there's a mismatch between what our ears are hearing and what our eyes are seeing, it creates a perceptual disconnect and it creates discomfort. And so what we don't have is that in our rooms is we have very low noise. We have very low noise or background noise, but then we have we design the acoustics specifically as well, in addition to achieving great playback for music. We also design it so that when you're in the room walking around or talking, it feels very natural, but we've taken away some of those small room acoustic cues for the speakers.
Yeah, very comfortable rooms, right? I mean, you made the point that you have clients that will just go into your spaces as to read a book. How blessed we'd all be if we had these low noise rooms as our retreat from just the noise of life. Right.
Yeah.
Government issued NC -5, NCB -5 rooms.
Yep.
Okay, well, this is probably the most important picture here. This is the inspection picture, right? But really, what we're getting into in the conversation now is this construction testing phase that you get into, and it's something that I find really interesting, because it's not just like, hey, we're going to send out a set of plans and hope that those plans are built. There is an interaction that's happening regularly with you guys and the construction team, and hoping you could walk me through a little bit of that quickly.
Yeah, absolutely. So through this process, we've kind of gone just straight past the fact that there's this huge construction documentation phase where we document all of the engineering and have, depending on the project, it might be 50 pages of drawings or 300 pages of drawings for some of our black label projects. And that just goes into the detail to make sure that everyone can understand the project and construct it as to achieve these performance metrics and this performance outcomes we're looking to achieve. So there's obviously a very close we work very closely with the general contractor to make sure they understand the design and the intent behind the design. But then obviously we have specific points in the project we want to go and test and verify that the system is, the room is on track to achieving the performance we're looking to achieve. So
Right.
we don't want to wait until the room's done to find out we have an acoustic issue with the sound isolation. So we have three primary points of testing, and this is the first one, and we call it the white box testing because, as you can see, the room's primarily white at this point. The sheetrock's in. We've got the baffle wall in this one at this point. Sometimes it's not there at this testing phase, but what we're doing at this point of the project is we are usually testing the sound isolation or the impact isolation of the room. So we want to make sure that all the floating floor, the box-in-box construction has been built correctly, because at this point the general contractor is prepared to pull walls out if they need to, because they'd rather do it then than once all the acoustics are in, all the architectural finishes are in. It's a much better time to identify that maybe something hasn't been built to spec and fix it. So it seems quite like to tear things or to pull out sawzalls and find a short in a wall seems like a kind of a big thing, but we find the project teams are much happier to identify and find that problem early on than later. Yeah. And in this picture as well, this was for our Han project, and this you can see a black square on the floor, and that was also the one of the calibration subwoofers or reference subwoofers we used for our Uber sub program. So these were placed to calibrate the boundary impedance of the room. We're also we've also got one of our omnidirectional sound sources, a 12-sided loudspeaker in the room. It's interesting to capture things like reverberation time in an empty space, just to kind of further calibrate our sheetrock absorption information at these low frequencies and mid frequencies. So we're always continuing the development and fine-tuning our simulation with reality as we go along in projects.
That's actually a really important point, right? Is that prediction is only as valid as it relates to the practical application and in the world, and making sure that those two are highly correlated is great to see.
We also have a black box phase test, which is where we have all the architectural finishes are installed. All the architectural finishes are installed, so say millwork or framing. The screen frame will be in. It's basically the whole room is complete. So you have carpet in at that point. All the acoustics are installed, speakers are installed, and so what we're doing at black box testing is verifying that the room acoustics are on track to achieving what we're looking for. And if we need to, we'll change some of those acoustics. We might swap out diffuser for another diffuser specific location, or change absorption for another type, or slightly change the orientation of an passive acoustic product. We might also tweak the loudspeaker position, so the screen channel speakers will actually listen, and we won't just play test tones and use the measurements to kind of give feedback, but we'll also be doing listening, and because what we're doing is a final verification step before the fabrics are installed, because once the fabric's up, we can't go back and change things. So that's what the black box test is. And then this picture here is the head and torso simulator we use to capture binaural room impulse responses, so we can go back later and convolve that and further confirm that against our simulation, because we simulate and listen and oralize rooms before they're actually finished. So we do the room acoustic simulation, and we have the opportunity to listen to what that room will sound like, and have our understand if the spatial impression we're looking to achieve is being given to us through these simulations. So it's nice to have the actual physically measured binaural room impulse response as well from the room, so we can compare simulation versus the finished room.
Right.
There's another tool here that it's just the core sound sound field microphone, and we use a software platform called Iris from Marshall Day Acoustics, and this allows us to not only capture impulse responses, it captures a spatial impulse response, but it not only allows us to analyze, reverberation time using this platform, but we can also look at, spatial parameters that might be applied to room design. We can also look at on the right side, you can see a 3D sound intensity vector, and we can, on this plot, we can see the red line would be the direct sound, and then the orange traces. We also call this sometimes a hedgehog in the industry. It kind of looks like a hedgehog, but the orange plots would have been sound that would have arrived between 2 and 10 milliseconds, and then the green will be within a different time period, and the blue will be, they continue on. But what we can look at is, where is energy coming from early? Where are we getting early reflections from? Where are they coming from? Because it's not always obvious where you might be getting energy from. Like something might be, you might have specified on a soffit that goes across the room, like a 1 foot wide soffit, you might have specified a specific amount of sound absorption, and the general cocta, it might all be black, and you don't really see it on a site inspection, but when you measure the room, you have a significant energy, an early reflection from that hard surface. Then you can identify the factors like that treatment wasn't installed there based per our drawings. So it helps us catch elements or things in the project like that. But it's also a great tool for just capturing and verifying that the design is on track to achieving the final intended result.
Verification.
Yep.
That's a common theme here, right? And so then also something that you're involved with here is that last step, right? Well, maybe it's not the very last step, but bringing the whole system together and the calibration and the reporting of the performance of that system.
Right. And so we've got the calibration step here shown in this picture, and it's where we're on site calibrating the sound system. And so what we're really doing is looking to linearize the response of the speaker. So, where you have speakers in, when you've actually installed speakers near close to boundaries, they're going to interact with that boundary, and they're going to interact with the room acoustics. So what we look to is flatten and linearize the frequency response of the speakers, and make sure that, we're integrating the low frequency effects or the low frequencies, and we're defining the bass management. And this calibration step is significant part of project, the final project, commissioning step. And for each one of these steps we've taken, the white box, the black box, this final test and calibration, we generate full reports that document all of the testing, the room acoustic metrics, and what standards cover those and define those metrics, and then we present the results measured in the room. And for some projects, we also did the same kind of reporting for we definitely provide reporting for our base camp studies and the room acoustic simulation when that's part of the scope. Is to some of our projects, we have a scope to provide a report and oralization, so the client can read what the process was to get to the design outcome, and also have the opportunity to listen to the room before it's even built. But this is a huge part. You're well aware of this, how important the calibration is in terms of having a system perform.
You might say it's the icing on the cake, right? It's
yes,
but you
absolutely.
have to make sure you build a solid or bake a solid cake before you can ice it. And I would like to point out the most important point of this image is that you have your hearing protection installed properly. Making sure that you take care of your most valuable tool, which are your ears. That's it can't be overstated enough. It's where are we here? All right. As we move forward, a lot of the rooms that you guys get into, and just something to really quickly make a note of, is that there are hybrid rooms, right? That these private cinemas are often have compliance for DCI compatibility of content that will be delivered to under DCP, and you also have the home entertainment implementation as well. And there will be a uniform loudspeaker implementation that has to work on all of those formats that will be delivered in that way. And you made a good point, is that, you have to choose your loudspeaker implementation that works best for all of the different immersive formats that are there. And and the reason I wanted to throw in this slide very specifically is just because of headroom requirements, right? This gets into the loudspeaker side of things a little bit more again, but it's really, as systems are designed that have to be able to play back the full dynamic range of DCI content, that's a different specification, right? We have to make sure that we can really linearly scale through that entire dynamic range, and make sure that each one of those surround loudspeakers, as well as the screen channels and the subwoofers, has the power to do that.
Yeah, and the very interesting thing is also that these hybrid systems, the Dolby home entertainment or residential content, the speaker layouts slightly differ slightly to the DCI Dolby Atmos layout. So we're looking to make sure that the speakers work for both options, for both sources,
Right.
and that's to make that really work. Takes a bit of work, and but this and as you said, the sound pressure level requirements that are dictated to be certified and approved for your Dolby CP850, if we use that as an example, to get access to the Atmos content that's on your DCI, that you have the luxury to have access to. That's a significant step, because they require that's actually achieved, the sound pressure level targets. So
that's right. And that's where Dolby is going to be involved in that, is that there's actually requirements in order to get those enablements for Atmos content. And just really quickly, a note to a reference level, right? Why is reference level important? And the key takeaway here, and I think everyone on this watching to this point of our conversation is up to speed, but just to say it, is that reference level is a predefined playback level with a predefined headroom requirement. And when we're talking about cinematic content, that is 20 dB of headroom over that reference level, or that volume that you set the system at. And it's important, from a loudspeaker manufacturer system design standpoint, that we know how that system will be used and what the requirements are, so that we design systems that are accurate and appropriate for the intended use. Because if you have a room, the example being, if you have a room that's not a DCI compliant space, and you're always going to be listening at a reference level of 82, right? We've got 3 dB of headroom in there if we designed to DCI compliance or SMPTE standards, that we may not need in that system. But maybe you also have music that you want to just let it rip. You want to really dig into that. So understanding that headroom requirement and how that boils down to the reference level of the room for cinematic content is important to me from the loudspeaker manufacturer side, and I would assume to you as well, Andrew.
Yeah, and that absolutely, that's very much reinforced by the fact that when Meyer Sound decided to go into developing a cinema line, that the first thing that Meyer Sound produced was a white paper on a review of all of the different pink noise types that are used to calibrate sound systems and to define reference level. And that white paper identified that there were some discrepancies between these different pink noises, and it was just really just a reinforcement of the fact that if we're going to do this, we're going to do it right, and we need to start at this, what's the definition of what is pink noise? Can we all agree on a standard unified type of pink noise with a certain crest factor that's at a specific level, doesn't shift 2 or 3 dB between the different sources that are generating it? And so,
and the answer was yes, we can. Now we have SMPTE 2095-1 is
right.
our SMPTE pink noise specification, which is in line with the Dolby pink noise, and now we are in a mode where we can lockstep and we know what noise files to use.
Yeah, and I think that just comes back to the fact that was just such a focus, and that it's if we're going to do this, if we're going to engineer speakers to achieve specific sound pressure levels linearly, then we need to know what the boundaries of the engineering, how do we need to engineer this, and have we all defined and agreed on what the actual performance metrics are? Because I think it's an easily misunderstood or misinterpreted, or it's not totally clear. When you start talking to people about 85 dBc, but then you have 20 dB peak within a 0 dB FS limit, for a lot of people, it's kind of like, it's slightly confusing terminology. And so the fact that we now have at least one standard that defines like what the pink noise to use is, and then we know that when we're just specifying a project, we're specifying it to achieve it, and to have the data from a manufacturer that's actually reliable is a huge element, right? Because that's all. That's everything. It's yeah, to have actual data we can pull from the Meyer Sound technical documents, and that says this speaker can produce this peak dBc SPL. That's huge to be able to actually specify based on a specification which is robust and has followed rigorous engineering protocol.
Well, and one point to make here, Andrew, and this is something that's so important for us at Meyer Sound, is that it's not just about taking our word for it, right? And this really is ultimately what the loudspeaker industry, and also just when it comes to system design, it's like, if the numbers that you're designing from don't equal the reality, there's a mismatch. And that verification, that last step of bringing that system in, together to reality to do what it's supposed to do, it might be a miss, and so we really have focused on bringing tools and procedures to the community to say, hey, don't just take our word for it or anybody else's word. Here is now, the M noise procedure and test tone, so that you can now measure and validate headroom performance of loudspeakers on your own, right? It's independently verifiable. And, ultimately that's what makes this whole community move forward together, is to say, here's some tools and new ways to evaluate performance of the components that are going into your system. And that's what gets, is really exciting for me, is to be able to say, hey, not only here are some products that we've developed that we feel are really good fit for the high-end critical listening rooms, and especially as we get into these immersive spaces, but here's a tool set to be able to validate that performance as well. And just really quickly on this slide, I invite anyone who's watching this conversation to reach out to me or us at Meyer Sound to talk about our solutions for the private cinema implementation, because we do have some really great tools here. And certainly we have, from our relationship with Andrew and many others out there, our product offering has evolved, and it's a really nice scalable product line. But the intention behind all of it is to have, linear performance, consistent, low distortion, consistent coverage pattern, and have systems that at the end of the day, they just work seamlessly. So Andrew, man, let's we went a little bit over our time here, but I think that's okay. And
Yeah.
like we said, each one of these points we really could dig into so much more. So I appreciate you kind of just bouncing along the top of this conversation so that we can start things off. And Merlijn, I don't know if we have an opportunity here to open things up to any questions, if anyone's still with us. But
sure. No, we still have viewers. All is good. So if you guys are amenable to questions, then I encourage those that are watching the webinar to post your questions in the comments of the Facebook stream. And then our panelists will try to answer your questions to the best of our abilities. So while that is taking place, I'm gonna make use of the opportunity to finish up with some household notes, which is that the recording of today's webinar, as always, can be found on our Thinking Sound YouTube channel within the next couple of hours or so. And we encourage you, we intend to keep you posted of future webinars. We have another webinar this Friday and continue to do so next week as well, obviously. So that concludes the household notes. And that means that if you have any questions, please put them in the comments. And we have a question coming in. Andrew, what are your favorite test songs?
It's a good question. There's definitely one definite one I have, because like the bass is so important, and it's so easy to have that off. And one of those would be Flight of the Cosmic Hippo. That's a really great, solid track that has
Bella Fleck.
you know,
Bella Fleck.
Bella Fleck. That's right, and that has some great sliding bass notes, so that really helps you identify whether. But it's also plucked bass, so it helps you identify whether you have a good tactile low frequency response, and then also whether the response is actually flat at low frequencies. So that's a great one. Oh, there's quite a few. And Miles, do you have any that are? Miles has some excellent references as well.
Well, there's two main pieces of content that I use, which is Isn't She Lovely, Livingston Taylor. That's a really great one for identifying phantom center and just implementation of left-right loudspeakers. And then another one that was put on my radar at ISE several years ago was Consensual Worlds by Delirium. That's got some really great psychoacoustic low frequency content to it that just spatializes from stereo implementation that just lets you know how your system is working together. But that's the toughest question ever, is when somebody asks you what your favorite track is, and it's like, tell us a joke. Hard to do on the spot.
Tricycle. I think Flight of the Cosmic Hippo. That's great. We have a really broad series of tracks that we use when we're assessing a system at the end. Straighten Up and Fly Right. I'm trying to recall the name of the artist on that one. I think that's Linda Ronstadt, who had that song, and then Jennifer Warnes' Lights of Louisiana. That's a solid one. Uno Mathemba, and I've pulled up, by this time I've pulled up my reference track list, but it's Lady Smith, Black Mambazo, Uno Mathemba. But that's a wonderful vocal track. Yeah.
Excellent. Well, on that note, I don't see any more questions in the comments. So that means that it's typically up to me to say motion to adjourn. Thank you very much, Andrew. Thank you very much, Miles. Very much looking forward to the continuation of these super exciting webinars. And to
Thank
our
you,
viewers.
Merlijn.
Sorry?
I was just going to say quickly, thank you, Merlijn, and thank you, Andrew. I really appreciate your time today.
Yeah, thanks for having us on. That was fantastic to share.
Awesome.
And converse.
Excellent. So to our viewership, I would like to say, as always, please stay safe, please stay healthy, and best to you and your loved ones. And see you this Friday. Bye-bye.